Okay, this is a recording of 7.4 Part 1 for Pre-Calculus on Wednesday, April 4th. And I ended up with a long lesson. If you were at the Feed My Starving Children on Tuesday, then I will have a recording on this. Either it's on my YOLA site now, or it might have to wait till I can get back to school, and then I'll post it on there. And it's just doing more of those problems. And that did turn out to be longer, so this is going to be a short introduction to 7.4 partial fractions, and then I'll give you the rest of the hour to work as you go through things. So partial fractions is our next section, and it's to recognize partial fraction decompositions of rational expressions, find partial fractional fraction decompositions of rational expressions. And so what I'm going to remind you of is in your past work in mathematics, you've maybe had a fraction like 1 over x plus 4 plus 2 over x minus 3, and you wanted to make those into a single fraction. Well, you had to get a common denominator of x plus 4 times x minus 3, multiply by things to make that common denominator that were equal to 1, and so forth. And then you got something, with x plus 4 and x minus 3 on the bottom, which is x squared plus x minus 12, and whatever it turned out to be on the top. So now in this section, what we're going to do is we're going to start with that big problem, that big fraction, and we're going to break it into these parts. So kind of think about reversing that process. We're going to factor this, and those different factors are going to be our different denominators, and then we have to find a way to get some numerators up here as we go. So that is the basic idea of what's happening here. And so in this section, here's a situation. We want to learn how to take something like x plus 7 over x squared minus x minus 6, and we want to turn it into 2 over x minus 3 plus negative 1 over x plus 2. And those two things are the partial fractions that add to be the big first fraction. So it says partial fraction decomposition of x plus 7 over x squared minus x minus 6 is equal to those two fractions added together. So now each fraction on the right side of that last equation was a partial fraction. Together they make up the partial fraction decomposition of the left side. And so the first thing I want you to do is just write down the directions for this. They seem very complicated. We'll come back and look at them tomorrow again. And after we do a few examples, they'll make a little more sense. But I do want you to write them down right now. And you can just pause this recording to write those. And I will just give you some time to do that. I want you to write them, but I'm not even barely going to talk about them. So go ahead and do that. And I'm going to move on. So I'm sure you need some time to write that, and then we'll move on. So if you want to pause this, go ahead. Otherwise, I'm going to go to the first problem. And we're just going to look at one problem today, kind of get our brains thinking about that. So in this one, I'm just going to tell you that I'm moving on, and we're going to be using this step 3 part, and I'll just leave that for you to know that that's what we're doing. And so here's our first problem, partial fraction decomposition. And this is going to be our problem. So it is actually that problem that you know the answer to, but we're just going to go through it. X plus 7 over x squared minus x minus 6. And I want to make that into the sum of some fractions that will will be the partial fractions using the factors of the denominator. So the first step I do is I factor the denominator. And in this case, that factors pretty easily. X squared is x times x. 6 is going to be 3 times 2. To make it -1, it'll be -3 and plus 2. So I've got my denominator. And now I'm going to write my sort of setup for the answer. So in a way, I'm writing almost the answer, except for I won't know what the numerators are. So x plus 7 over x squared minus x minus 6 is equal to something, I'm just going to call it a, over x minus 3 plus something, I'm going to call it b, over x plus 2. And so I'm going to actually just take a moment. Oh, and I didn't mean to move all that. I'm going to take a moment and just clone that little piece and put it away for later. And I'm going to clone this little piece also, just so that then I can work with them. And I'll be bringing those back at the end of the problem, but I just want to set them over there so that I have them handy when I need them. So now we have this situation. The first thing we're going to do is just multiply everything, both sides of the equation, by the common denominator so that we can get rid of the fractions completely. And so I know that that factored into x minus 3 and x plus 2, so I'm going to go x minus 3 times x plus 2 times that, x minus 3 times x plus 2 times that, and x minus 3 times x plus 2 times that one. And then I'm going to cancel things. That whole denominator on the left cancels, so I'm going to end up with x plus 7 over there. Here the x minus 3's cancel, here the x plus 2's cancel, and then what is left here is x plus 7 equals a times x plus 2, in parentheses, plus b times x minus 3. So that's what I have, and now I'm going to just put a little box around that because I'm going to work with this, and I get to pick convenient values for x and then figure out what a and b are. Well, I can pick anything I want, but then I might get a system of equations. I have to do a lot of work. So I'm going to write myself a note that I'm going to pick convenient values for x. And then I'm even going to write in parentheses, if I can find things that will make these factors equal to 0, like x plus 2 and x minus 3, then that will be super convenient to me because I'll have less work to do. So I want factors of x plus 2 and x minus 3 to be so factors x minus 2 are equal to 0. And sometimes I'll be able to do that, sometimes I won't. In this case, it'll be super easy for me to do. So what makes x plus 2 equal to 0? X equals -2. So we'll just say let x equal -2. And then I'm putting that in that big blue box and figuring out what either a or b is as I do that. So let me slide that down, and I'm going to take -2 plus 7 equals a times -2 plus 2 plus b times -2 minus 3. And over here, I'm going to get 5 equals, that is 0a, and this is -5b. When I divide by -5, I get b equals -1. So I've got that part done, and then I'm going to do the same thing over here. I'm also going to let, for my next situation, if I wanted to make x minus 3 equal to 0, x would equal +3. So let x equal 3, and then I'm putting that in that big box equation again, and so 3 plus 7 equals a times, in parentheses, 3 plus 2 plus b times times, in parentheses, 3 minus 3. Well, that'll be 10 equals 5a, and then b times 3 minus 3 is 0. And then divide by 2, so I get a equals 2. And somehow over here I made my b into a lowercase b. It really doesn't matter, but I'll just kind of fix that as is. Now, remember I had just written these and then I cloned them and then I put them down here. So now I'm going to put that back into my problem. And look, I just figured out what a and b were. So that a can go there, this b can go there, and then I will have my partial fraction decomposition. So my answer is x plus 7 over x squared minus x minus 6 equals 2 over x minus 3 plus negative 1 over x plus 2. And that is our first partial fraction decomposition. And now I'm just going to make up for yesterday. This was about less than 12 minutes, and I'm going to give you the rest of the hour to work on homework assignments. So I will see you tomorrow. Have a good rest of your day.